Hello students, today we are going to study about the Fajan's rule. It is a topic of chemistry, 11th standard chemical bonding. See what happened, bonding is a chemical process which binds two atom molecules, ions together and the formation of molecule or compound takes place. Here we have two types of mainly bonding, electrovalent bonding and covalent bonding. If one atom loses electron and form cation and another atom accept electron and form anion. Okay, these are the cations and these are the anions. And due to the formation of anion and cation, electrostatic force exert between them, and this is called electrovalent bonding or ionic bonding or non-rigid, non-directional bonding. Such bonding will produce a compound with high melting point, boiling point, high solubility in polar solvents, and high thermal stability due to electrostatic force of attraction. Now here, these are the covalent bonds, electrovalent bonds, and formed by metal and non-metal. Okay, this is the bonding formed between metal and non-metal. Those having low ionization energy loses electron, another is high electron affinity or electronegativity, accept electron form anion. And whatever the process undergoes, it is due to the tendency to achieve inert gas configuration. It loses electron to form neon configuration and it accepts electron to form helium neon argon configuration. So these are called the inert gas configuration, and every element tries to get inert gas configuration or to complete its octet, they undergo bonding. Now in similar way, what is the covalent bonding? Covalent bonding means there is a sharing of electron. Sharing of electron is covalent bond, and in covalent bond the boiling point, melting points, solubility is very less. But in case of covalent bond, solubility is high and thermal stability is high because of strong electrostatic force of attraction. In case of covalent bond, means this overlapping of orbital takes place, and such bonding is called covalent bonding. Like if we have hydrogen and we have p orbital of chlorine, so you will get HCl, means H bond Cl. This is a sigma bonding, and this type of bonding is called covalent bond. These are two types, polar or non-polar. Now we must know what is the polarization or polar character. If cation size is smaller, very smaller, and anion size are bigger, okay, like chlorine, like sodium ion, okay. This is the chloride ion, this is the sodium ion. I will give the idea about the ions, ionic radius and size of the ion. I will give the values, so you will come to know. So sodium ion is very smaller because when it loses one electron, the nuclear charge over other orbitals or orbits will increase and the atom shrinks. And sodium ion becomes smaller as compared to the chlorine ion. Now there is a electrostatic force exert between them and electrovalent bonding occurs. But what happens? 100% electrovalent bonding is not possible. Some nature of covalent character is also there because of its positive character, its negative character. Okay. Now what will happen? Now we will study about the polarization. Polarization means polar. Polar means plus and minus. If plus and minus is there, the same amount of plus and same amount of minus is there, means 2 coulomb positive, 2 coulomb negative, 2 microcoulomb positive, 2 microcoulomb negative. If we have together them, then means it is a polar. So, what is how the polarization occurs? If we consider lithium, it is lithium, very small size of lithium. This is called cation, and bigger size of means chlorine. This is a anion. Okay. So what will happen due to its smaller size? High charge is there. High positive charge density. High positive charge density is there. So it has greater tendency to attract electrons of the chlorine. Now here too much of electrons are present in the chlorine, and there two things occurs. Ek to size become bigger and the electronic repulsion is there. And due to electronic repulsion, due to bigger size, it can't control the size. So this positive charge attracts this electron cloud towards itself, so it get polarized like this. Okay, this is a polarization, means this negative charge, it comes over here, it becomes little negative and it becomes little positive. So since this polarization occurs, and this is the positive charge in the nucleus, so it undergoes sharing, means that positive charge and this undergoes sharing, and this is the covalent character. So covalency is arises. Covalency arises. That is the Fajan's rule. According to Fajan's, what happened? Fajans describes the factor that influence the covalent character of ionic compound. Means even though lithium is from sodium family, lithium, sodium, potassium, beryllium, magnesium, calcium, barium and all. In this way, aluminum and all. Okay. So as you go left to right in a periodic table, you see the size of the atom decreases. Means when you see the Shah Rukh Khan cap of Yes Boss, the size of the atom left to right decreases. So, if we see left to right, if the size going on decreasing, if it is this much of positive, this will be lesser positive, the lesser size, and this will be more lesser. If it go more lesser, size means more positive charge density. It means it has a greater tendency to form covalent bond. So, according to Fajans, it describes the influence of covalent character of ionic bond. Means ionic compound has some covalent character due to its polarization. Means if the size of the cation is smaller, it has great tendency to polarize. And the size of anion is bigger, it has great tendency to get polarized. So, get polarized, it should be bigger. To make it make polarization in other, it should be smaller. So, according to Fajans, what are the factors responsible for the covalent nature? Cation size should be small. Smaller the cation size, greater is the charge density, positive charge density, and it has a greater polarizability. It can easily polarize the anion. Now, anion size, bigger the size of anion, greater repulsion occurs, means electronic repulsion occurs, and nucleus is very far from the electrons, and there means the electrons are very much free to move as compared to the earlier stage of the chlorine. So they get get repulsion between them, and they are very free. So when there is a positive charge comes, the whole negative reaches towards the positive and it get polarized, and due to greater polarization, greater is the covalent character. If greater polarization, greater covalent character. So size of the cation should be smaller, anion size should be bigger, and the charge of the ion means if Na positive, single charge, Mg positive, double charge, aluminum triple positive, more charge. Greater the charge, greater has a tendency to polarize. Similarly, you see carbonate double minus, OH single minus, Cl single minus. Okay, so this is also there. So if greater minus charge is there, greater electrons are there, so it has a great tendency to get polarized. Now here we have some questions. Lithium chloride. Why lithium chloride is not soluble in water? Why lithium chloride is soluble in water? Because even though sodium chloride, potassium chloride, they are soluble in water because ionic compounds have a tendency to get dissolved in the polar solvents. But in case of lithium chloride, it has a smaller cation and bigger anion, so it get polarized and it get little covalent character. So it has a covalent character, means lithium chloride is covalent in nature. You can say lithium chloride is covalent in nature, that's why it is having low solubility, low melting point, boiling point, and it cannot be dissolved in water. Lithium chloride case you came to know. Now, here the silver iodide and silver chloride. See, this is the bigger size as compared to the chlorine, means size of anion is bigger. So more bigger anion means more bigger covalent character. Here the silver is same, Ag positive is a single, but here iodine is bigger than chlorine. That's why it has a greater covalent character than AgCl. Now Mg3N2 and MgF2. Fluorine is very means more electronegative character, but here you see magnesium and here also magnesium. Both magnesium are same, but here the size of this is uh, means greater electronic repulsion in case of fluorine, so it has a covalent character. Now here the thermal stability also, barium hydroxide is more thermal stable than the magnesium hydroxide, because down the group size of the atom increases. As the size of the atom increases, more ionic character is there, so it has a more ionic character. Now here beryllium chloride, some will say BeC, why BeCl2 is covalent, why boron trifluoride is covalent. You can say it due to its high electrode negativity or very small size of cation, the polarization occurs and covalent character is there. Now, one more thing, copper, cuprous chloride, CuCl and NaCl. So you can say uh, covalent character, covalent character in CuCl is greater, means sodium chloride is greater, the covalent character than the CuCl. But in case of copper, there is a pseudo covalent, pseudo inert gas configuration 3s2, 3p6, 3d10. Their pseudo character means what happened in case of copper, poor shielding effect occurs, so it cannot affect the electron cloud and atom gets shrink. So this is also character. So you came to know about the Fajan's rule. So I will explain little. I have this. I have written all these things. You just listen. According to Fajans, he describes the factor that influence the covalent character of the ionic bond. It predicts that bond between smaller cation and larger anion will have greater covalent character. The rule states that the higher the charge on cation or anion, or smaller the cation and larger the anion, covalent character of bond is there. The increase in covalent character is due to polarization of anion by cation. Means due to cation in anion polarization occurs. Polarization is what? In ionic compound, the cation positive charge density attracts the electron of the anion and the distortion takes place and the polarization occurs. This distortion gives the bond a partial covalent character, means little sharing is there. Now, what are the factors? Cations should be smaller, and if they are smaller, means high charge density and greater ability to polarize the anion, and hence the cation should have high polarizability. Now here anion size should be larger, so electrons are repulsion is there, and the electrons are very free, loosely bounded, so they are easy to get polarized. Now the charge on ions, higher the charge on ions, either the cation or anion lead the strong electrostatic interaction, and the greater polarization occurs. Greater the covalent nature, lesser is the boiling point, melting point, solubility, and thermal stability. So, in ionic character, ionic compound, there is a high melting point, boiling point, high thermal stability, and solubility. So, you must came to know about all these Fajan's rule. Overall, it tells about the covalent nature in ionic compound. So, bye bye, students. Have a nice time. Means you will get a lot of questions in complex exams also. Bye bye.